Okay, let's try the next part of this analytical geometry thing. The first thing here, show that the coordinates of D are 6 and 11. That right up here, show that that point is 6 and 11. Well, I didn't get it right away. Oops. But this is what I thought of. I thought, oh, we've got the equation of this line here, dB, and we've got the equation of dC. We should just let them equal each other, and that's what you do. This minus 2x plus 23 that we learned in the last question, let it equal 3x minus 7, and watch what happens. You take away 3x, you take away 23, you divide by -5, and x equals 6. That's what we want. Put that 6 in here, 3 times 6 minus 7, and you get 11. There, we just showed that D is 6 and 11. Calculate the angle EBC. EBC, this angle right in here. Well, we've got two lines, and we know the equation. We know the gradient of this line is 3. We learned that the gradient of this line is a half. All we have to do is get their angles of inclinations. And how do we do that? We go shift tan of 3 and shift tan of a half, and if we subtract, we get the angles in between. And if we do this, shift tan of 3 minus shift tan of a half, hey, it works out to be exactly 45 degrees. That's nice. So we've done that. Now, this one, I had to think about it at first. They said, figure out DF. And then I thought, oh, DF is a tangent. Tangents are perpendicular. Hey, Pythagoras would work here. Oh, we could figure out AD just using the distance formula. And don't we know what this is? Do we know what this is? Yeah, we do know. It's root 10. Because, hey, we've got the equation of the circle. So AF squared is 10 squared. AF is the square root of 10. So we've got two parts of a right angle triangle. We can figure out, and we've got the hypotenuse here. Is that the hypotenuse? No, this AD is the hypotenuse. We've got it. We've got a short side. We just have to subtract and take the square root, and we'll get the distance DF. And that's what we do. First, we figure out AD squared. That's what I did. I went 6 minus 4 squared, 11 minus 5 squared, 2 squared, 6 squared. That's 40. And R squared, we already knew it. R squared is 10. Now, what do you do with Pythagoras? We can use Pythagoras because DF is perpendicular to the radius. So DF squared must be the hypotenuse 40, hypotenuse squared, minus the other short side squared, 10. And by Pythagoras, DF squared must be 40 minus 10, which is 30. So DF must be the square root of 30. And that is your answer. All done.